How's everybody doing out there? Well, hopefully everybody did a good job figuring out how to identify when to use fundamental counting, when to use permutation, when to use combination. And if you did, again, it's going to make this section a lot easier, because ultimately what we're doing is now going to use these counting techniques to apply them to probabilities. So instead of using the fundamental counting once, we'll end up using, say, for example, fundamental counting twice, once on the top number, once on the bottom number. Same thing with combinations, same thing with permutations. So let's go ahead and dive in with some examples so we can see what's going on. So for example 1, we've got big pens. Make pens in 4 different colors: blue, black, red, and green, with 3 different tip styles: extra fine, fine, and medium. What's the probability of picking one pen at random and having it be a black pen? So first thing we want to notice, so we've got kind of our 2 categories going on here. We've got the pen colors, we've got the tip styles. So this is crying out for fundamental counting principle in this case. And so when we're trying to calculate our probability in general, so remember what we're trying to do is we're trying to figure out the number of elements total, which is going to be our bottom number, and the number of ways that our thing that we're interested in can be formed. So for this one, if we want to try to find the probability of a black pen, then in words, what we're looking for is first we need to figure out how many total pens can be made for our bottom number. And for our top number, we just want to know how many black pens there are total. So typically with these, the bottom number is going to be usually the easier one to calculate because there's no restriction. We're trying to calculate the total, and that's technically what we did in section 3.4. We were always trying to calculate the total. So I'm going to always usually do the bottoms first for these. So I'm going to go ahead and use my little box method here and draw my 2 boxes. So since I had 4 colors available, so my first box I can put down the number 4. And so for my second box is the number of tip styles. So I have 3 of those available. So 4 times 3 is going to give me a bottom number of 12. Now for the top number, I want to, again, draw my 2 little boxes. But for this one, I want to guarantee that we have a black pen. So the only color that we're interested in is just black. So that means we can throw out blue, throw out red, throw out green. So that's forcing us to have just one single choice, the black pens. Now we still can have any kind of tip style we want: extra fine, fine, and medium. So that can still be okay. That's just going to be 3. And so again, when we multiply, 1 times 3 is 3. 3 over 12 would simplify down to 1/4. Again, you don't necessarily have to simplify it, but so 3 out of 12 or 1/4, there's a 1/4 probability of getting a black pen for this one. All right, so again, this was a nice fundamental counting problem. Looks good. So let's take a look at example 2. So in this case, we're dealing with either permutations or combinations, just to kind of let you know. So with this one, we've got a standard deck of playing cards, has 52 cards. Suppose we're dealt 3 cards. What's the probability that all 3 cards are queens? So just like I had mentioned in the previous video, if you're dealing with cards and they don't mention anything about order matters, then that's automatically going to be a combination. So this one's going to be a nice combination problem for this one. And so what we're doing is we're trying to find the probability of 3 queens. So again, like from a word perspective, we're trying to figure out the total number of 3 card hands possible. It's going to be our bottom. And then so the top, we want to make sure that all 3 cards are queens. So we need all 3 cards to be queens. So again, sometimes the top number is the trickier one to figure out. The bottom number, again, is exactly what we did in the last section. So if I want to figure out the total number of all 3 card hands available, then in this case, since there's 52 cards total in our deck, and we're choosing 3, so our bottom number is just going to be 52C3 for this one. Now the top, we've got a restriction because we only want to make sure we have queens in our hand. So we're not allowing for aces, kings, twos, threes, any other cards. So when we're talking about the total number of cards available, our total in this case is just going to be 4 because we're restricting our attention to just queens and only queens. So of those 4 queens, how many ways can we choose 3 from those 4 queens? So our top number is going to be 4C3. Our bottom number is going to be 52C3. All right, and so I'm going to type these in the calculator real quick just so we can see what they look like. And so I'm going to type them separate first, and then I'll do them as a division just so you can see what it looks like. Again, sometimes these numbers get so small, like the decimals usually aren't necessarily the best way to go. A lot of times I just leave them as a fraction, but I'll show you just so you can see what it looks like. All right, so let's flip over to our calculator here. And so we're going to do our 4C3. So we're going to go to Math, PRB, NCR. So 4C3 is our 4, so that's nice and straightforward. And then our next one is 52C3. And so that's 22,100. So if we were to type this, write it down, we're going to get 4 over 22,100. And again, this probably does simplify, but I'm not going to simplify it or anything like that. I'm just going to leave it in that form. And so if we were to type it in the calculator to see what it looked like as a decimal, you could actually type this in exactly the way we did above. You could do Math 4C3 and then divided by Math 52C3. But you're going to possibly end up with something like this, so that e to the negative 4. So what that means is it's scientific notation, and so it means we want to move our decimal point 4 places to the left. So this would actually be the same as like 0.000180099. So it's a relatively small number. So that's why a lot of the times in this section, I don't like to use the decimals because the answers look like they're almost 0, or again, we're going to get some weird results. So again, I would recommend leaving all these answers in fraction form. It's just going to make life much, much nicer. All right, so let's go back here and take a look at the probability that all 3 cards are hearts. So I'm just going to write these in the C form. I'm going to let you guys type them into the calculator yourself. So I'm just going to put them in the C form and stuff for the rest of this section. But all right, so the probability of 3 hearts. So again, I'm not going to write out the words. I think we've got the idea of it at the moment. So our bottom number is going to be exactly the same, the total number of 3 card hands, which is going to be our 52C3. So our top number, since in this case we're focused only on hearts, since there's 13 hearts in the deck, we only want to choose from those 13, and then we are going to choose 3 of them, so we're going to end up with 13C3 over 52C3 for our probability of 3 hearts. And again, you can type this in the calculator later. I'm just going to leave it at this for now. All right, so finally, what's the probability that all 3 cards are red cards? So again, bottom number, exactly the same, 52C3, because nothing's changed in the style of this problem. But now, since we want to have either hearts or diamonds as our red cards, now we have 26 possible red cards. And from there, we're again choosing 3. So we'll end up with our 26C3 over 52C3. And so again, go back later, type these in the calculator, or do it now so you can fill it along in your notes what the numbers would look like. But again, make sure you leave them in fraction form. All right, so that's our combination. And so finally, example 3, by process of elimination, I assume it's going to be a permutation, but let's check. So assume we're still in charge of the movie marathon. So we had our 4 types of movies: action, comedy, drama, and horror. Assume someone else brought a thriller to be included in the marathon. In order to find out the order of the movies, you decide to throw all the names in a hat. Plan to draw one name out of the hat at a time. The order will be determined by how they are pulled out of the hat. What's the probability of the thriller being played 4th and the horror movie being played 5th? So in this case, we're looking for the probability of the horror 4th and the thriller 4th, sorry, and the horror 5th. All right. So again, our bottom number is going to be the probability of all possible ways we can show all 5 movies. So how many total ways can we show all 5 movies? So with this one, if we set up our little rectangle or boxes here, so we've got 5 choices for our first, 4, 3, 2, 1, which is going to give us, was that 120? Yep, 120. Now on the top, this is where our restriction comes in, because we want to guarantee that the thriller is 4th and the horror is 5th. So when we lay these out, we can go ahead and put in the T for thriller and the horror for H in that 4th and 5th position. So we really only have control over the first 3 movies, and we only have control over action, comedy, and drama. So what that means is we've got 3 choices for that first movie, 2 choices for the second, and then finally 1 choice for the third, which is going to give us 6 out of 120. Now, if you don't like the box method and you like using the little P formula better, what this would look like in terms of the P formula, since we had 5 movies for the bottom and we chose all 5, we'd have 5P5 on the bottom, and for the top we had access to 3 total movies and we placed all 3 of them, so we'd end up with 3P3 on the top. All right, perfect everybody, perfect. So what I'm going to do is I've got a ton of practice problems here for you guys to work on. So again, there's a variety of fundamental counting, permutations, combinations. If you get stuck or anything, feel free. I'm going to reach out to other classmates and stuff like that. These would be good ones to kind of share answers with and try to work on with each other and stuff like that, because these can be a little bit tricky. So kind of go through these last couple practice. I think I got like 11 of them or something like that, because I wanted to make sure we had them down. If there's any you get stuck on or have confusion about, definitely let me know so I can like write something up or make a little video or something like that. But definitely message me, let me know how you're doing, because this can be a tricky section. So good luck everybody. Let me know if you get stuck, and I will see you in the last section.